Hi there. When the cold snap hit quite a few weeks ago now, it was far too cold in the workshop to do anything. So I got thinking about sort of doing a little bit of programming, Arduino stuff, out, inside on the computer. And I'd seen something about LED displays, the 8x8 LED displays, which you can sort of join together. So I thought, oh, it'd be an idea to have a play around with stuff like that. So I got an ESP32 and did a bit of programming on that, displaying some information on this display. And then I thought, well, the ESP32 has got a Wi-Fi capability. So if I can attach to my internal Wi-Fi network, I should then be able to get the current date and time off the internet. And I managed to do that, and then convert it to British summertime when it needs to be converted. So all that went sort of swimmingly well, and then I thought, well, it'd be nice to actually show the inside temperature of the workshop. And I thought, well, I've got a little module, a temperature module. What was it? A BMP 280. So I attached that to another Arduino board, an Uno, and started reading the temperature off that. And then I thought, well, I've actually got something out in the garden that transmits the outside temperature and humidity to a display up in the bedroom. So it'd be great if I could capture that. And that transmits at 433 megahertz. So I did a bit of an investigation and realised I could buy a little module, a receiver, a 433 megahertz receiver, to actually intercept the signal being sent from the garden, and to decode the information to actually acquire the outside temperature and humidity as it's displayed upstairs. So I managed to get that working on the Uno, and then I thought, well, it'd be great if I could get this information off the Uno onto the ESP32 to display on my LED display. So I joined them together using a serial connection, and lo and behold, that's the result. So that's the current date from the internet, and that's the current time, GMT. The inside temperature, 21.2, so that's pretty good. Outside temperature currently 11.8 degrees C, which is really good for this time of the year. And humidity, 66%. And there's a little Pac-Man there that comes across. Unbelievable what you can do nowadays with these little Arduino CPU boards. So that's what I've been messing around with, and it was really enjoyable, to be honest. But anyway, as you can see, the temperature's got a little bit better in the workshop. So what I'm going to try and do is to make the gears for the Upshur opposed twin. Now there are two gears required, both 48 dp. There's a 60 tooth one and a 30 tooth one, and the outside diameters, as defined on the drawing, is 60 plus 2 divided by 48, which gives 1.292, and the outside diameter of the 30 tooth is 30 plus 2 divided by 48, which comes in at 0.667 of an inch. Now the PCD, where the teeth engage on each of them, is calculated by taking the number of teeth, dividing it by the dp. So that gives the PCD of 1.25 for the 60 tooth one, and for the 30 tooth one it comes in at 0.625 of an inch. So the distance between centres is equal to 1.25 plus 0.625 divided by 2, and that gives 0.9375, which equates to what's in the drawing, or thereabouts. Now, I've made the blanks already. They're just straightforward, really. The big one in brass and the small one in leaded steel. And I've made 3 lots. Obviously one lot for me, and a pair for Jim in Thailand. Jim can't get hold of 48DP gear cutters, and I know even in the UK they're pretty rare. I was fortunate to get some when I was making the I think it was Cherry Owl V twin. I got them from the States, and I've got another spare set. And if people who are making this engine are struggling to get 48DP gears, what you could always do is to make them out of mod 0.5 gear cutters. So these are the working outs for mod 0.5, and to get the distance between centres close to this, I've worked out that if you go for a 64 tooth gear for the large one, that gives 66 multiplied by 0.5, so that gives 33 millimetres outside diameter, which is equatable to, well, it's equal to 1.299 of an inch. And the 32 tooth gear is 34 multiplied by 0.5, which gives 17 millimetres, which is 0.669 of an inch. So the PCD, if you're going to go with mod 0.5, will be 64 multiplied by 0.5, which is 32 millimetres. And the 32 teeth gear will be 32 multiplied by 0.5, which will give 16 millimetres. So the distance between centres, if you're going to go with mod 0.5, would be 32 plus 16 divided by 2, which is 24 millimetres, which is 0.945 of an inch, which is pretty close to 0.9375. I think it's 77.5 thou out. But distance between centres is quite critical for gears. So if you've already drilled that hole there based on the drawing, and you're going to go with mod 0.5, it's going to be 7.5 thou out. So there we have it. So I will have a spare pair going, hopefully, and if anybody is making this engine and they haven't got mod 0.5 and they've not got 48DP gear cutters, then I could let them have that. But I would need proof that you're making the engine. I mean, you could make them out of 0.6, mod 0.6 really, if you were to work out maths. So there's, there are alternatives. So this is my gear cutting setup. So I've bolted the rotary table down as best I can, making sure that it's at right angles with the milling table. And I've just cut this point on this piece of metal and put it in this collet, and I've just lined up this to make sure it's at the same position height wise. See if I can zoom in on that. That looks pretty close. And now I need to make sure that the cutter is spot on centre with that point there. And that looks pretty close, I think. And now I've locked the Z-axis. Okay, so I've just moved the Y-axis in until these cutter teeth just touch the brass. There you go, just touching. So I'll set the DRO to 0. Move this out of the way. So I need to move the Y-axis in by 45 thou now. That's for 48 DP cutters. 45 thou. Lock the table. I've set the limit switches on the X-axis. Checked that the cutter number is the correct one for 60 teeth, and that is cutter number for 60 teeth. It's cutter number 2. If you're using mod gear cutters, that would be cutter number 7 for 60 teeth. Okay, so I've got the World of Ward division controller set up to 60 teeth. I shall rotate the table by 1 increment, then I'll lock it. So we should be good to go. Okay, so I'll continue like this until I've completed all the 60 teeth, then I'll get back to you. And the final one. So this is the mandrel I've just made for the smaller gears. I've used some super glue again for the blanks, and it's really just a matter of making sure you've got enough space each side so the cutter don't clash with the stuff on the mill. But obviously if it's too long then it could flex. And I've used this support to get the Z-axis on centre. So it looks like we're just about good to go. Okay, so like last time I touched the cutter teeth on the edge of the blanks, and then I've advanced the Y-axis in by 45 thou, and obviously you need to make sure you got the right gear cutter in there for 30 teeth, and this is cutter number 4 for DP. Now if you're using mod cutters, you'd use cutter number 5 by my reckoning. And I've set the World of Ward controller to 30 teeth. I backed it off a bit and then advanced it again, just to get rid of any possible backlash. So we're in division number 1 of 30 at the moment. I've locked the table. I've locked the rotary table. Turn the mill on. Everything's bolted down nicely. And I think we're ready to go. Make our first cut. The table, advance by 1 increment and repeat. Okay, I'll get back to you once I've completed all the 30 teeth. Well, they seem to have turned out okay. And just to demonstrate that the gears mesh nicely together, I've put this camshaft through here, albeit these gears will run on the inside of the engine and not the outside of the engine. But it's just to prove that they mesh nicely. And they do. Happy with that result. Well, I must say preparation is key, and certainly when making gears I probably spent a lot more time doing the setup than I did actually cutting the gears. Now, I think previously in the video I mentioned not being able to get hold of 48 DP gear cutters in the UK. Now, looking back, I think it was the 32 DP gear cutters that I struggled with, and I got some of those from the USA. Now, looking at my 48 DP gear cutters, 3 have come from RDG Tools in the UK, and I think I only paid about £25 each. So if you are looking to make some gears and you need some cutters, check out RDG Tools. I know their stock levels fluctuate quite a lot, so if they've got them in stock, I'd snap them up pretty quickly. Alternatively, there's a company in Chesterfield called HPC Gears who sell a massive range of gears, and no doubt they'll sell the gears that sort of I've made. The only thing you would have to do is to maybe re-drill the centre to be the right size and maybe the width. They're not cheap. I've never used the company, but I know they're not cheap, and by the time you've bought a couple of gears, you could have bought a couple of gear cutters. And like I also mentioned, I've made 3 sets, one for me, one for Jim in Thailand, and a spare set. Now, if anybody is really struggling and they are making this Upshur Post Twin, I could donate that pair of gears to that person. But I would insist that they provide us with evidence that they're actually making the engine. I don't want to just send them to somebody who's just curious, if you get my drift. But anyway, I think that's all I've got to say. Things are warming up, which is good. So I hope you enjoyed the video, and I hope to see you later.